Testing 1, 2. Yeah, thunder. No, it's not real. But well, you shouldn't have asked. Imagine that it is real. How much better is that? A procedural thunderstorm. That is interesting. Yeah. No, it's real. Yeah, it's just, but not live. it's a recording with a microphone. Pretty sure of that. Or well, then again, I don't know. Anyway, I was going to code. I just can't decide what to do. We have sample 0 here and then sample 1 here. Then we fit the whole cubic. And we jump to the extreme, the maximum of that cubic, which happens to be exactly where 0 was already. I can detect that 0 and 2 are on top of each other or very close, but then what to do? It seems to me that the only really logical thing to do is to ignore, well, not insert 2 and just use 0. Let's start with that. It's not even that easy. I need to scale. My scale is part of sample node, I thought. Yeah. I use IBP even though I don't use abbreviations. I just use IBP often enough that it warrants, you know, an what is it called? Acronym. That stands for iterator Boolean pair. So that's just what a lot of standard library functions return as well. I just have to return the IPP here, no matter what. But the cool thing about this is that since we return the by value something here, only one viewer. So is the viewer there or not? Well, that's strange. What? I'm just not using it at all. Okay. What is that called? There we go. No existing memory. Might as well add a notice card to everything that returns something. I mean, I don't want to discard these returns either. Okay, so now what I want to do is, I think my boolean is set to true if the iterator is valid. So basically the result return type of duplicate. So yeah, it's set to true if the iterator is valid, which means that they are a duplicate. if they are a duplicate, okay, this is true, or this is true. So we get here. Then I want to do something and then jump back to I guess basically the top of the function. Maybe I should do an iterative call. Recursive call, I mean, I don't know, let's not do this, otherwise it would blink in and out of existence. So that seems not super useful. I just have to update current, and then I guess well, there's no new sample. There's no new sample. I mean, I'm using reusing an old sample. That's already drawn. I don't need to draw it again. So we can update current and then not do this. Do I need to update the energy? No, it's an old sample. So maybe jump back to this point. Even though initialization is not set. Could jump back here. Let's do it here. So I'm making a new loop, forever loop. Which we break out from here. But now in this case we can just continue at the top here. Then I have to change current. Current is just sample. So we can assign the iterator to it. Oh, I see what this does. Right, so this is equals in. I did run find larger with a non-zero value, and then we see me re-enter the function or just jump to the top with 0. And well, those values are not exactly the same. Therefore, this assert fires. I suppose I have to set larger to the next sample of that iterator and change the new value. Yeah, or not. I should not insert a new sample, so I don't think new W is then tested, is it? Where is this tested? Yeah, in insert. I don't want to call insert, so really it should not be necessary. Handle exit. At this point, to jump back in a way that I'm not adding stuff. I'm afraid I have to jump past that and past it. This. Ugh. So annoying. So incredibly annoying. Is this ever going to have that problem? Initialization, I think not then. No, I should not. Shouldn't say. No, I should not. Do not have that problem. So maybe what you need to do is duplicate this code. Just gonna call this, call it a day. New node is in thing that is inserted. Moving current, yeah, I see. Updating current is nonsense. Should not do that. I should just set new node. MVP handle exits, just break or set new node. We're using sample new node. Then we jump here, running states, say it's still the same. Well, whatever it was set, it's like an re-entry here, but then without the insert. This should work. And if not, then I'll hopefully have the testsuite fail. Which bloody test is this? First cubic. This is so weird. Why is it calling it twice in a row? I think I know why. It's a testsuite thing. New probe -3 is too close to an existing sample -3. Okay, and why do we probe 3? Yeah, this is the same thing that went later wrong. I think -3 is the maximum, so we start in the maximum, then we go past it as a result of calling handle single sample. And then now we have a cubic, we jump back to the extreme, which was this -3. And before that worked apparently. But this time it refuses to return -3 because it's a duplicate of the thing that we already had. And then the test suite doesn't have a chance to abort because it's not being returned to the test suite. So this cubic is initialized. Find extreme, turning the maximum, calculating the scale, and then we would normally return -3 here. We call find larger, which already prepares us up for the re-entry. Then we already know where to insert a new -3. So it's going to be inserted before -2. However, then it doesn't return like it did before. Now it says that -3 is too close to the first sample. Reusing that sample, so we don't return. Then it runs find extreme again. Runs the exact same initialized cubic. Was already initialized. And then what do we get? There's no left cubic. And the right cubic has no extreme between -3 and -2. Dubious, but not totally incorrect. Okay. Yeah, I know some assembly or knew, but it was a very, very, very long time ago. But I did code in assembly when I was really young. Later I did write some assembly just for C++ code. You know, with the ASM thing. Really? Yeah, I don't know. That's there are two possibilities. I'm gonna start with skipping this, I think. So I'm gonna skip first cubic. Go straight to local extreme. Oh no, I'm here anyway. Let's skip. Let's start immediately at. Um, I0 is the Imax value. So put 2 here. Okay, so now we get immediately this problem here. And it has become the same problem, okay. Even though this is the next test, the previous test wasn't drawing stuff, but it's the same thing. We just enter at the maximum at -3, and then we do -2, and then we jump back to -3, and that's the problem at the moment. So we did do an initialization of the cubic again between -2 and -3. So here we did that also. That was the first time. Now based on the first time, this is while running first cubic. So it's different code even. So it just initializes the cubic and then finds the best extreme. Pick the maximum, which is at -3. Calculate the scale. Then we want to find where to insert a -3. And it says inserted before -2. Yeah, or label 1 here. So the new -3, that is will be at the same place as 0 here, must be inserted before 1. But it must also be in between 0 and 1. And since it is exactly at 0, it's not really in between. It's like, yeah, maybe large or equal will solve it, but definitely hesitating doing that, because floating point round off errors might break that another day. This is such an edge case, of course, that one of the edges is already exactly at the maximum. Everybody else in the world would just write something like, if the derivative is almost 0, then we found it. But I don't like constants. I mean, what is almost 0? 10 to the power -12? I mean, what? I don't know. What I want to do it more robust, more abstract, which makes it very, very difficult for some reason. So abstract would be not to look at almost 0, whatever that means, but there's doing the algorithm, and the algorithm should do, we have a 0, and then we have a 1, then we jump back to here, and then we would fit again. I mean, we jump a distance, we jump again a distance, but now we are in find extreme, so then the next jump should also be to this point, which is then a very, very small step of size 0, and then it says, okay, now we found it. But that does mean that it must be able to find this extreme, even though it's only very, very edge. And it's rejecting it, basically. Now we are even worse, maybe. We're dealing with sample number 0 here, because I literally say, okay, do sample 0 again. So that says there is no left cubic. Well, that's actually correct. I think left here just means, yeah, more negative. So we are here and there is no cubic on this side because there is no sample on this side. So I can't complain about that one. But that means that the right cubic is the one between 0 and 1, which does not have an extreme between -3 and 2. Well, it does, and exactly on top of it. This floating point round-off errors is so annoying, it's unbelievable. Now I have already detected that it is a right max cubic, which means it is the right part of a maximum, which like literally says that the -3 is a maximum. So if we would rely on this type here, then it would be easy. I would just say, oh, it's a right max. Okay, we're done. We have the maximum found. We found the maximum. But it only detects that it is a right maximum because I'm using a very special cubic, which has all integers as coefficients, as well as a solution for the extremes, which then are also integers. So everything is integers in the hope that floating point round-off errors wouldn't too much mess with my test suite. So it allows me to test certain edge cases where things are exactly 0 and stuff like that. So this is indeed exactly -3. Although I have seen -3.00000000004, so it doesn't always work apparently. Yeah. What? I don't think I agree with the arrow here to the right. I'm looking for this maximum. Why the hell should it be to the right of the maximum itself? It just doesn't make much sense. When is that arrow set? Immediately. So it kind of sucks. This is my right off thing, so somewhere I'm setting right off. First point -3. And on single sample we want to go to -2.875. But then the test suite forces it to go to -2. We're entering at -2. Which is level 1. Running first cubic, initialized between -2 and -3. -3. And then the result is this cubic. And here this is the extreme, I'm pretty sure. And if not, then it is extreme, so yeah. Simple node find extreme -2. So passes, it calls find extreme on the cubic, I think. Yeah, it's just a cubic. I mean, this is this object, -3, which is on the left, which is the one that contains the cubic. Turning maximum because that extreme is closest to the center of the two given samples, aka -2 and -3. So I have -2.5. It's in between, and then the maximum is closer than the minimum, which is like all the way over there to 14. And then what happens? I think then next extreme type is already set to maximum. Yep. And W is set to -3 because that is the extreme. And the node on the left is also -3. So it is not less than, but it could be. Could have been. Due to round-off errors. No, -3 is definitely less or equal -2, so here we set right off. That's my right off, right? I mean, it's like the left node is the -3 thing. Yep. So this is where it happens. Why? It's more like, yeah, it's doing this because that was not true. That's not correct. I mean, it's like even in the light of having no floating point around of errors, it's just not correct. If it is equal, then it should not be left off. Right off, I mean. Right off sounds like not equal. Well, then again, if I make this less than or equal, then I would say, okay, then it must be left of that. No. So I have to change the meaning of left off, as in left of or on top of left node. That at the very least, that should be the meaning. In which case it would set left off instead of right off. What? That is also nonsense. I don't want to set it at all. I mean, we're on top of it. What if I only set this if it is significantly left off or right off? Did I already set a scale at this point? It's 106. Nope, scale is initialized here. But that doesn't use left off and right off, does it? Oh, it does. Man, the way I call this means that both must be set. Oh no, I was planning on not setting one of them. Just sits. doesn't really use it. It just sets it. Why these things are different meaning. Left edge has a particular meaning within the scale algorithm, but the left off is something else. So why did I confuse the things here? Good. Left node and right node. See, I'm in blind. That's left node, right node is not left off, right off. So they are not being used. I thought I was being used, but it's not true. So we can move this up till above the part that is doing the left or right of stuff. The scale is using the used cubic. Okay, so this is nicely immediately as after that is being set ish. So I could move it up. Probably the cubic should be initialized, so I think this is as high as we can get scale. And then I can use the scale here maybe to define a sense of significance. Well, that was better, I think. Didn't crash. Looks like now we jump back to 0 and then refuse to add it because it's equal to 0. Therefore we just reuse 0 and then we initialize this cubic again and jump again to 0 and then doing you keep jumping to 0, but it never stops. Now why is that? So we reuse the sample at -3, okay, label 0. We run find extreme state. It's initializing the cubic again, which is kind of silly, but this is a super rare case anyway, so I don't care. It again decides to use the same thing, nothing changed there. Therefore we go to -3. Scale is, everything is done the same as before. So we do probe -3, and then it says it's too close to an existing sample, which is true, but I think it should abort before that point. If we didn't make any significant step. The step then would be the distance between the previous probe, which is clearly 0 already here. So the jump back from one to here is a step of -1, but then the next time we get there again, and then it's step 0. However, it tells me the step is 1. So that's wrong. Why is the step 1 according to this thing? So look at where that is printed. It's using chain lost. It's just nonsense. Lost. Oh, right. Yeah. Lost is supposed to be pointing to the last sample, but I did not do that. So we have to update lost as well then. So extreme change lost must be updated when we change I think when duplicate returns true, it also has to change to lost. Well, that is, where's lost normally set? Oh, lost is normally set when insert is being called. Yeah. I'm skipping insert now. I'm not sure I should do that in duplicate. It's not really belong there. Duplicate. Okay, I could do it and handle exit, I guess. This is the most logical place to do it. Reusing a sample and then jumping back below the insert. I'm just gonna do a reuse here or something. chain dot reuse node. So now chain knows about it as well, as it were. Yeah, sorry, I've said last, must be a non-const iterator. Is last? Why is last actually just an iterator and not a const iterator? Not sure I have a non-const iterator here, so. Lost. Larger equals lost, but that is a const iterator. So absolutely nothing. We try to make this a const iterator. And I've got where it was. Oh yeah. So this is then a const iterator. Yes, host is node. It's a bit vague. If you call reuse, then that should kind of call find larger again. But larger was already changed by or was it? Larger is not set at all, actually. Because I'm not calling insert, I'm no longer interested in updating larger. Running finish, but it doesn't finish. But okay, it also doesn't loop. Tries to finish at least. So now we have a 0 and 1, and then it does put the 2 on top of 0. That is maybe the finish thing here. What exactly happens here? Cool, -3, then -2. And then we don't print this. We should just print a running thing. Two, 3 minus 2, and then it says we want to jump to minus 3, but it's so close that we just reuse sample minus 3 or sample 0. And then we want to reuse 3 again. We want to jump to minus 3 again, but again we want to not do that. And this time it doesn't say reusing sample. What is that? It does say so here. Probably because we are not jumping to the top, or yeah, we should. So running something. Where is this printed? Reusing sample. Maybe I call handle exit somewhere else and then I don't follow up with that. Now calling it here. This is just debug code. Really, I should be handling a local extreme here. I'm trying to exit, as it were, and ignoring the return value of exit. Why is that not giving me a warning? Or is it giving me a warning? No, just a warning. Yeah. I guess this. Is it possible that then the local extreme needs to reuse a sample? Theoretically. It's kind of always possible, I guess. This is the end of find extreme, and this is the end of first cubic. This one can't even restart. The whole design is wrong. I mean, not everything. Rewrite 3, but this particular reuse thing, what I previously I didn't have that going back to the top and reuse an old sample thing. So I just used that handle functions, and then when we arrived at a point where some special case occurred, I would just do return, handle, whatever, and then we always exit the function, and this thing then takes care of everything, and by the time that returns, it just returns the correct value and we're done. So the rest of the code of this function is no longer interesting because this thing handles everything. However, now I want to be able to end up in a state where I want to reuse an existing sample. Which means that we have to exit the switch. And then we get here. And then call handle exit because we are about to exit. But. Okay, well then this function then takes care of finding the next point of insertion over W, and if that is too close to an existing sample, we want to reuse that sample, meaning that we don't break here but set a new node to point to that point, print that we're reusing it, update the chain, tell the chain that we are doing that, and then just jump to the beginning of the function instead of returning. However, does not jump to the beginning of the sample, which is also never necessary because we are never going to redo initialize. So I'm skipping handling the energy, which is probably also not super logical, but I suppose you can get away with that. I do not want to insert the previous sample, of course. So I just updated new node, so you get here. Seems to make sense. So yeah, I think I want to do that like always then. This means I should not do a return unless I return false. Return false there is okay. So this is a construct that is no longer allowed or possible. What I can do then, if not handle local extreme, then return false. And otherwise break out. Is that correct? Probably, except of course that handle exit then should not be called by handle local extreme. I think currently it is. Okay. And here we do the same thing, but I don't want to change the state after returning from handle local extreme, so we have to do that last and make the same construct here. If not, return false. The only problem now is that no, this is not a problem yet. This is the first cubic state that will work. I just don't want to have a return inside the initialization, because then I don't know what to do. Even before initialization, I'll have a return. It'll abort H direction. So theoretically that should be included as well, and I think in this scheme, so if handle abort H direction, I'm not really using H direction anymore actually. Now do something. If that returns false, we should return false. But if it returns true, then it would be a very good idea to call handle exit and allow us to reuse an existing sample. So I think it's safe to assume that we're already past the initialization state by the time that this can be called. So I can split it up into calling it inside this and then later. And then the later one can make use of the return. Put it past that endless for loop, aka here. Then I would do that after inserting the new one in the chain. That's okay, that this can be done. I don't have that. Surely I have another only. That's this one. Oh, it's the same one. Debug only. I want it to be defined when assert is defined only. Equals right after you do an assert. So now this can be moved down. So now you do find that the step is 0 after entering -3 for the second time. So -3 first here, -3, and then -2. Just can't print it again. Nope. U probe -3. It's too close. Reusing sample -3. Running found extreme. And then it wants to use -3 again. What the hell? Step is 0, but still this. Oh no, that's okay. So step is 0, therefore we enter handle local extreme. And handle local extreme just tries to exit because it didn't implement it yet. It's a bit unclear how we go from here to here though. Okay, it just sets to finish. And then returns. Still returns true. Oh, yeah, finish once one more sample. Return true, so we do continue. And then that one more sample, this becomes the old sample, the previous sample, the same sample. So we go here, and then we run finish. I think I just have to add some debug code here. Nobody else should be calling handle exit anymore. I think I'm gonna move it here. Hmm. Unknown state. Oh, shocking. Should never have re-entered, of course. Never have re-entered, I think. Yes, we call this after that one returned false. It's very possible actually. Yeah. Yeah. Yeah, what is this about? Yeah. The floating point round of errors strike again, or this one. It's not equal to that. Randomly larger or smaller. I don't understand the comment though. I mean, it's just wrong, that comment. It should say if only one extreme would fall in between the samples and derivatives must have the same sign. No, wait a minute. Then the... Oh, can't have the same sign. It's actually correct, of course. So I think that what's going on is this, that probably this 2 is with the floating point around of noise. I guess left of the green arrow here, tiny a little bit. Which means that the extreme, the maximum here, falls in between big quotes 0 and 2. But at the same time, the calculated derivative of 2 is positive. Wait a minute, negative, I mean. Which of course cannot be true. I mean, if 2 was here, then the derivative would have been positive. But since it's in the noise of the floating point round off errors, it's actually the randomly left or right of it and has a random derivative. So the derivative has a different sign than this one, which is negative. No, sorry. This one has a negative derivative as well. So the sign of the derivatives are the same. Therefore, there must be 0 or 2 extremes in between. Now this one's clearly not in between. So this one can also not be in between. But we just detected that that one is in between. No, probably because the extreme is less than W. And the get extreme is 14. No, it's not true. This one. Next, -2 is less than 14. Okay, I lost it. I think we detected that it did not fall in between then. So the other one is also not allowed to fall in between. But it does, because we must be comparing this and this. So that is these two. So this is smaller than that. Doesn't even look smaller. Well, it should have been smaller, but it isn't. Yes, -2 is not smaller than -3. This one, this extreme should have been smaller than W, because we needed to fall in between, because the derivatives have a different sign, I guess. I still don't get it, but okay. Ach, maar ook, hey. Well, everything must be is the first. Well, the first time, yeah, okay. Never once seen. I don't think anyone else does it. So, in my opinion, it's super boring. But on the other hand, if you're not a coder or you're thinking about becoming a coder and you have absolutely no idea what that is, be a coder, what does it mean? Well, then you will be doing this the whole day. Sort of. It's, if you watch a random YouTube about programming, then everything seems so easy and simple, but that's not how it is in real life. It's a never-ending fight to understand what the hell is going on. Week after week after week. That's why it's boring to watch. Okay, now how to solve this. I try to understand the exact reason here, but I failed. Nevertheless, it's just floating point Randolph errors. And I'm pretty sure that maybe I should just compare the derivatives that I have. If you have that, and we probably also have DLDW. We don't. Why not? I have W. Why would I not have? Of course I have a DLTW. If I have these two. There it is. So this one's negative, and then next must be TL to W. Nope, doesn't want to print it. Oops. Also not. No, you gotta be kidding me. There it is. That one is very negative, and then the one that is 0 is yeah, also negative, but basically 0. But still, the sign is the same. But because the sign is the same, you would say, well, that means that the point is on the right of the extreme. Otherwise, the derivative should not have been negative. So it must be in a very small little bit to the left, to the right, I mean, of the extreme. And then the assert fires because that comparison fails. So again, my sample must be on the right, so larger than the extreme itself. And now we're talking about the extreme that has this value. So we must compare that with, well, the thing that has about the same value, that would be W. So this must be larger than that one, and indeed it is not. It's on the left. It's more negative than that one, so it's a bit on the left. It's not larger. And that's why the assert fails. Now, how to solve it? 99.9% of professional coders would just delete the assert. But we're not going to do that, right? No, we want to really understand what's going on. You cannot ignore it. I mean, I'm using the same tests here, so something is going wrong. What is going wrong? Correct thing is probably to have a broader sense of equal, for which I need to scale, for which I need a cubic. Well, I have the cubic here. No, I don't need a cubic. I need an object that contains the cubic. Forgot which object contains scale, really. No idea. It's not a node. Put it next, for example. Scale. A scale of 7. So, hey, yeah. Actually. No, it is this one. The cubic between 0 and 1 is next. And well, we should be talking, I think, about this cubic. Between 2, the one fitted between 2 and 0. And that then would be not next, but just the current object into this, which also has a scale. There's the scale, and the scale is 0. Sensor. How the hell did it get 0? Yeah, it's completely uninitialized. This is a typical double value with all zeros. Well, maybe not, because that's different, but uninitialized anyway. Yes, also different. Random values gives you a very small double usually. I can see that the scale is not initialized because the cubic is not initialized, which you can see because the type is unknown, even though the thing has super sensible values. Still uninitialized. Strange that. Okay, this tells me that scale cannot be used. Unacceptable. Of course this thing has a scale. This is inside initialized cubic. Yeah, no, we don't have a scale yet. Oh, wow, yeah. Don't tell me I need a scale inside initialized cubic. Oh well, any scale will do. I'll just pick the distance between 0 and 2. At most that scale gets larger, combining it with other samples, which would not even be the case in this case. And it doesn't matter using just 0, 2, unless these two would be extremely close together. But this kind of means I need to change my formulas such that they do not suffer from this floating point roundoff error if the 2 points are super close together. And one of them is in an extreme, close to it. It seems a bit, well, it feels like maybe I should store my cubics in a different way, depending on if we are in the neighborhood of an extreme. Right now I just store them like this: a plus bw plus cw squared plus dw to the power 3, which is very good working for mathematics, but not so for my computer program, which has to calculate this, and then with all the floating point roundoff errors. If both my samples mean, each cubic has two samples. If both samples are very close to a given extreme, and that could be either this one or that one, then I should build my formula around that extreme. So we calculate the extreme and then store the extreme, and that is then still still has round off error. Well, that is then the canonical value. I mean, I just assume that then whatever the round off error is doesn't exist, and I declare it exact. And then the rest of the cubic then is based on that, so that in super close to that extreme, we just work with really small doubles, but not floating point round off errors, which means that all my signs and stuff and left and right is going to be correct all the time. I think, yeah, I had the feeling that this is the way to go, because I'm getting completely crazy of the round off errors that I have here continuously. That's quite a big change, though. I'm gonna have to think about this for a bit. I don't feel up to doing this right now. Good. Yeah. Let me play a game of chess. Watch a movie, eat dinner. And you in that order, obviously, have to get up to make dinner. Make dinner? Oh shit, I have to make dinner. I have to defrost some chicken. So I probably have to get up anyway, but it already started. I'll defrost my chicken after this game, and then I can play until it is has melted. Yeah, that's what I wanted to do. Sicilian. Finally got it. Oh, wait, this doesn't look like what I wanted. But he gives me a pawn. Really? This guy gives me a pawn? Why? No, I don't see the problem. I can just pick this pawn. Let me get a check here, and I lose my knight. Interesting. Something we can do about that? Yes, I can defend this square. No, I can just move my knight when he takes it like that. No, the thing is pinned, so I can't. But if I take here and he takes there, I just take the queen with check. So that's he has to take back like that. Then I can take again with check, and then this thing is already gone. So okay, but now I do this, then I have a pawn, but then the bishop comes here, and I have to move my queen and lose my knight. That would not be good, of course. Can't take the rook. I'm gonna go back, I think. Can't give check. My queen is defending both checks anyway. Plus, well, the knight is gone. I did not lose a piece, but knight threat to give check here is still not really a problem, because I can put my knight in between. He takes it, and then if I take back, he takes this pawn, attacking my rook. But then I can take your check and pick up the rook. But that last move is not worth check, or is it? Could put the knight in between, I guess. Could take here, it takes my rook. Is that with check? If not, then I can take the bishop. If the bishop was put in between, then I take even with check. But then attacked or not? No, not attacked. The king cannot. I think it's totally possible, really. Totally possible. So I move this, for example, and then we give check. Go here. Take. Take here, check. I can't castle then anymore because then my knight is also attacked. But it feels like if I take here and he takes my rook, he does take my rook with check. So I do this with check. If I move the bishop, I take with check and then castle. That would be good. Then I get a rook against for a knight. And if he, I don't know. I'm just gonna do it. I put like 3 minutes in this move. I put 3 minutes in it, and he doesn't even take the bait. Now I'm going to do this. Pum pum pum, the knight's going here. Where's tempo on the queen? I'm doing it anyway because I have to develop my bishop. Oh, funny move. Yeah, why not? Cement it in. I can't move my knight because it's kind of pinned, except I could go there. Oh, king attack. If the knight comes here and I move forward, then what happens? I think I can ignore it. Man, this is tough. Okay, it's pretty tough. I don't know what to do. Let's see, what is my greatest weakness here? This one. Yeah, I think that is not the best move, but it should be possible. Oh, it takes it with the knight. I didn't consider this move. Ouch! That is not good. Okay, he's gonna take with the knight, and then I'm almost dead. Then that's what. So we can do this. Man, he could even sacrifice a bishop there. Just play this pawn. Oh, I'm so dead. This is really bad. What did I do? Can go forward, take, go here. And then hope for the best. Yeah, I hope for the best because I have no time left even. Attack tonight. Okay, one double check coming up. No, it's not even a double check. Oh, he's gonna go there. Blah, blah. Only move. And then if he takes there, this is again the only move, right? He's thinking ahead. That's pretty smart. Oh, my pieces are so bad placed. Oh, these are both super bad, which is also a movie. Pretty good movie too. I think he gave away the queen now, but well, what can you do? Maybe I'm gonna win. I'm gonna win. Probably best move, take the rook. Oh, that's smart. But if I go here, oh wait, he's threatening mate. Let's just take it. And that was pretty damn smart. I had totally not seen that one coming. Taking a pawn. The pawn comes forward. I guess I go to g3. I should have taken the pawn probably. No, my rook is not defended. I can't take the pawn. No, I cannot take the pawn. That is pretty nasty, yeah. Having this little time. Unbelievable. Give away this pawn. I gave away the pawn. I don't want it. Nah, man, that move is pretty bad as well. Probably should have gone there. That was pretty bad. That was pretty bad. He's gonna exchange this one, of course. And then he's gonna take there. Come on with the pawn. Move the pawn forward. F4, you can do it. It's also doable, but not what I expected. I mean, I had not seen the check. That's what I mean, of course. I'm going to win on time. So this guy is so slow. What is this? Okay, I move it away and now give me mate. I think he's going to move a pawn because he thinks, no, I can't. Check is probably the best thing to do here. And then check again and then they take this pawn. No, wait, yeah, well. What you gonna do? That's the only move. Now I should be able to take here. Or not. What do you think? Check. Yeah, I have to go there. No, probably give check again. It is ultra lame. Let's go here. Unclear as hell. I don't know what to do. I have no clue what to do. I could go here actually. Let's take it. And check here. I can't stop it anymore. And made in one. Seriously? Oh, I didn't see the made in one. This is also made in one? Yeah, now it's that made in one. 1.3 seconds left. Almost, but disastrously bad. Okay, defrost the chicken. Gee, my curtains are still closed. Might as well keep them closed. It's going to be dark soon, I guess. A few hours. Okay, that was horrible. So, let's play another game. My favorite. But he is not taking here now, of course not. He's now taking there. And then the best move was what? I think this one. But I'm not sure. I need to actually study that. Really? Oh really? Oh really? I can just defend it. I can also push it. I don't really want to push it. This control looks nice. Okay, I'll defend it. I'll go out of, wait, here I mean. I can go here and here. And here. No. Here. Here. Yeah. How come I can't punish this guy, or haven't punished this guy for not castling? was a good move here. No. Nope. No. Wow. You can't even move all that. How can I make use of this double ball, man? Okay, is it tagging something twice? Push it, maybe. It takes there. No good. Defend it like that. Make room for the king as well. Just play a rook there. Double attack. I wouldn't even know how to defend. Well, I have to play the bishop here then, I guess. No, I can just take here. Not sure. And maybe push this. Yeah, definitely push this. Try him out. It's a good thing they tell me that I'm playing the black pieces, because I was so confused. Thought I was playing white. See, apply e4. Now wait until my opponent moves. Let's not do that against a 2000 player. Oops. Yeah, that was stupid. A little bit. No, might as well resign now. Christ. It is the truth. Suckage. What is with the white squares here? I could just sacrifice my bishop and I give check, and he goes in the corner. And my queen comes here with threat and mate in one. Oh, the knight can still defend it. Yeah, doesn't really work. Well, it almost works. Could go here, for example. So I take, check, goes there. Queen here. And didn't work. It did not work like that. Well, no. Damn it. Why? I can go here. Pretend I didn't see it. Another bishop is coming, of course. Totally going to take here now. It was my move, I would take here. Yeah, not now. Now I won't do that. Now I will just go here. And then the knight comes there. Gee, it never stops. Never stops. I have something though. That's why this guy is thinking this long. But he's the only one seeing it. Well, of course, if I move that one, I take the rook. But then they could just move the rook now. And apparently he's scared. And the only thing I can think of that he could be scared about is me giving check here. Yeah, I need that knight for all my attacks. So you can't have it. What about I give check, take, and then I'm not even threatening anything. Just gave away. I just gave away a piece. This is not good. It's not good enough. Now I need to take with the bishop. This is not working, man. Shit. Yeah, I'm just gonna do it. And then yes, check here as well, and then my bishop is gone. It's horrible. Yeah, and I don't have any other option now, of course. So at least I'm threatening to take maybe here. It's the second pawn. No, still nothing. It's ridiculous. Pointless, useless. Probably should have taken the knight. At least then I threatened infinite check here. Ah, that was stupid. Why the hell didn't I do that? Got a point there. I feel like offering a draw just to, you know, fuck his clock up. That's not very nice, is it? Would not be very nice. Oh, he took my queen. I'm gonna resign this, dude. Shit. Shit. That makes me depressed, man. It's a draw position. White is better. Much better. Winning better. Yeah, I should have taken the knight here. That was a draw. I mean, the bishop is attacked, so logical that you just remove it. But rather than taking my rook, wow, can you imagine? And then it's just infinite check. Sort of half a second too late. That was the whole idea of my sacrifices there. So how bad was the sacrifice itself? Pretty bad. Not that bad. Wait, let's go to the sacrifice. It is the best move. Wow, I'm a grandmaster. So, but I'm losing. And here I should not have taken the first take there. Yeah, why not? If he takes me, that's nasty. Nastier than removing this bishop. He takes back and then take it here. And now I'm threatening nothing. Well, no, not really. Plus 2.5. Yeah, the computer will defend everything. Or maybe I wanted to threaten to take this, that's why I didn't take that. Can't even exit the page. Everything is frozen. This page is doomed. You're watching a dead page. A segmentation error. Oh, finally I could close it. Is my chicken defrosted already, or do I have to start coding again? I'll be right back. Okay, I'm gonna make dinner.